Dear students, in this session we will explain how to determine the required sample size. If the margin of error E and confidence level are specified in advance, then we must determine the sample size required to meet these specifications. If margin of error is specified as say 2 and confidence level is say 95%, then we have to determine n, the sample size, to satisfy these two requirements. Now, we have defined E as Z alpha by 2 sigma by root n. And solving this equation for the margin of error, we can determine the required sample size. Root n is equal to Z alpha by 2 sigma by E. So that n is equal to Z alpha by 2 sigma by E square. So the required sample size is Z alpha by 2 into sigma by E the whole square. So the sample size required for a confidence level, say 100 into 1 minus alpha percent, a confidence level equal to 100 into 1 minus alpha percent, and also a given margin of error is obtained by solving this equation. Z alpha by 2 is given, E is given, sigma is unknown, that we will see how sigma is actually inserted here. Then required sample size can be calculated. Now to explain this, again consider the how to calculate the average age of the civilian labor force. Now suppose that, and we know that sigma is equal to 12.1. Suppose that E is specified as 0.5 years. 0.5 years to either side of mean. Confidence level is 0.95 or what is known as, so alpha is 0.05 and Z 0.025 is equal to 1.96. Now, the required sample size n is Z alpha by 2 1.96 into 12.1 square by 0.5 square is equal to 2250. It means if you select randomly 2250 samples, then 2250 samples, you will get a confidence level of 95% and E is equal to 0.5. So if you specify the confidence level as 95%, margin of error as 0.5, then a total of 2250 samples are required. Let us see whether this is true or not. Now, 43 X bar, suppose that X bar obtained is 43.8 using 2250 samples. Then 43.8 minus 1.96 12 by 1 into root of 2250 is equal to this quantity is equal to 43.3.5 less, and if it is plus, it is 44.3. So 43.8, 44.3, 43.3. So confidence interval is stated in advance. Confidence interval is stated in advance. E is also stated in advance. So required sample size is 2240. And remember this, to calculate this value sigma must be known. But in most cases sigma is unknown. So the procedure is, you take a large sample and obtain the sample standard deviation S. Obtain this sample standard deviation S and substitute S for sigma here. S for sigma here, and you calculate the required sample size. And remember this, if you specify the confidence interval, confidence level in advance, and margin of error also, a small margin of error requires a large sample size. Because n is negatively related to this, it will be highly costly, and in many cases it will not be practical. If you give a margin of error as 2 square, then n will be considerably smaller. You can experiment with the different values of n. Also, confidence interval determines the value 1.96. Reducing the confidence interval reduces the required sample size, like that. So this is the sample size required for calculating a single population mean mu using X bar. And this is not applicable to other cases. This is applicable only in the case of arithmetic mean. That should always be kept in mind, this formula for calculating the required sample size. Remember, when E margin of error is stated, also confidence level is stated in advance. You want a particular confidence level, you also want a particular margin of error. Then the required sample size can be calculated. That is it.